My background is I started in astronomy and physics and astronomy, and then studied space engineering and worked on the design of the International Space Station for NASA. Um, and one thing I should point out is that um, I changed paths. I thought I was going into astronomy, and then after 10 years, I switched to space engineering and space station design. A message for young people, I used to think that you had to go in a straight line, for whatever you wanted to do. But actually, everybody I worked with had gone and changed directions, changed careers, taken different opportunities. And so that's one message, is that, you may just have an interest in background, and then someday later you may come back to it. So it's not a straight line. But I wanted to talk about perspective over decades, over lifetimes. So this is the global air and ship traffic network. And of course I use that today, but I also used it from when I grew up in a small town in North Carolina. I didn't think I was going to travel around to other countries, but eventually I was interested in that, and eventually I did travel to many countries, and I actually ended up 5 years ago moving to New Zealand. But I had no idea when I was young that I would end up living in another country. And so that's another message, is that when you're starting out in life, you may not know what opportunities are available to you in the future. And if you look at a longer perspective, the 95 years ago, Charles Lindbergh flew from New York to Paris and made people aware of the potential for air travel. Anybody who flew in a plane was called an aeronaut, and a few people were flying in air travel. One flight on a plane might cost about as much as a house. And so, but he ended up making people aware of the potential of air travel. After his flight, he traveled around the US, and he convinced all these cities to start building airports because of the potential of the future of air travel. And up there in Minnesota, my father, when he was a child, saw Charles Lindbergh and his visit when he was convincing, Chicago and San Francisco to start building airports. And the next year after this was Auckland started to build an airfield for air travel. But when my father grew up, he saw the evolution of the entire air traffic system. So in another change that has happened over decades is the increasing power of computing power. It's hard to see on this, but on the tick marks on the left is like every tick mark is a factor of 100 increase. If you in the past 50 years, it's gone up by a factor of 1 trillion in power. During this increase, we've had personal computers, we've had the internet and smartphones, and all those transformations have happened just with this increasing in power of computers. And another message of that trend is that trend will continue, so that someday we'll look at our smartphones like I look at my punch cards that I used to use. All the Apollo computers, if you add them up, is just one smartphone is 240 million times more powerful. So that means that when my friends are creating a lunar lander with 6 people, they don't have to worry about the design of the computers for the lunar lander. It's the computing power is enough to do this. It also enables things like the computers are fast enough to direct the rocket nozzles for landing these large stages from SpaceX, and that makes the getting into space much cheaper. One thing that we do at SpaceBase is we use this power of the computing power and available satellite data to address problems like climate change. And we ran a competition recently with offering $40,000 prizes to address climate change and we had a university and a high school winners in this. These challenges are the top priority to address, and these new tools that we have available are allowing us to monitor the effects of climate change and potentially come up with the solutions. But what I wanted to talk about is the other direction, which is the potential for what these tools do to open up the solar system. And I think we're going to see in the coming decades a vast expanse of increase in the number of people going into the solar system. Now, right now, the NASA program is starting with the Artemis missions, and both of these vehicles should be doing their test flights in the next couple months. The SpaceX Starship on the right is a reusable vehicle. Up here is the landing of two astronauts on the moon using both of those big rockets. But down here is the first mission, is the Capstone mission. This was launched last week from New Zealand. So it's really remarkable that the first mission of the NASA program was launched from New Zealand. So with Apollo, we had 6 landings with 2 astronauts each. But this is the vehicle for Artemis landings. SpaceX was asked to design a vehicle that could carry 4 people to the moon. They came back with one that could carry 50 people. So it just gives you an indication of the scale of activity that's just starting in a few years. Also, a former student of mine from 20 years ago became a NASA astronaut. She has a chance to be the first woman on the moon. But where is this leading? This is a company, United Launch Alliance, that is a combination of Lockheed and Boeing. And their projection is that in 30 years, they will need 1,000 people at the moon just for propellant production, for producing large spacecraft such as the space solar power satellites that collect energy and transmit it down to Earth for clean energy. At SpaceBase, we're working on how do we keep New Zealand involved in this. And these are some of the areas that we're working on. One company is figuring out how to make solar cells out of lunar material. There's research on propellant management and food production. There's a company over here, a professor at University of Canterbury, that is making a lunar concrete, which concrete out of simulated lunar material. And he's been working on that for a few years and now has a company to do that. But the potential in the future, and I think in just a few decades, is going to be thousands of people at the moon. And the design of these interiors, from being able to fly inside pressurized structures at 1/6 gravity, or not needing stairs because you can jump from floor to floor. All the details of this will have yet to be designed or figured out, and that's really the young people today have the potential for making those choices of what we do on the moon and how we do that. But I think there's a potential in the coming decades, in the lifetime of young people today, to see the start of cities on the moon. But the other area that that fascinates me is the potential for asteroids, for near-Earth objects. These are asteroids and comets that orbit close to the Earth. And back when I was interested in this, first started being interested, we knew about 12 of them. And we used to argue about which one would be the best one to visit. Now we know about 29,000 and about with a dozen discovered every week. In red are the near-Earth objects that come close to the Earth. In green dots are the main belt asteroids. So this is backing out all the way to the orbit of Jupiter to show how many of these things are out there. And comets are the blue boxes. So this is an animation of there's the main belt asteroids there. And this will focus on the near-Earth objects, which are the asteroids that come close to the Earth. Each of these plots in this diagram is a real orbit, a real object. When these things are discovered, they're evaluated over a period of hours or a few days to detect whether or not there's a risk of hitting the Earth. And none of the big objects have any risk of hitting the Earth, not the ones that we've seen, but the search goes on. There was you may have heard that there was an object a couple of days ago that hit during the daytime near Wellington that was about the size of a car and detonated in the atmosphere. And this is a little meteorite sample of a piece of a metal asteroid. I mean, this little sample is actually older than the Earth. It was formed before the Earth formed. But there's here are some of the images of asteroids that spacecraft have flown by. You can see that this is in true color, so that Matilda asteroid is really that dark, for example. The bigger ones are in the main belt. Some of the smaller ones are near-Earth objects. If you picture for raw material, if you picture adding up all the material of all the cities on Earth and putting them together, then you get an object about the size of Tutatis over here. And I'll show you, this is Tutatis over Auckland. So, yeah, we don't want that to happen. But this is the raw material for building structures in space. So there's a lot of interest in scientific interest in visiting these because these are samples of the original formation of the solar system. But they're also great raw material, and people are looking at how you extract that and convert it into, oxygen, silicon, water, metals, etc. Everything you need to build space structures. And there's the one way to look at these things is that each of these mountains in space is a potential future space city. So there's also certain asteroids, carbonaceous chondrites, that are great raw material for soil. So that all you need to do is you bring the life and the microbes to the soil, you can start to have things grow in space. And so that can be a challenge to this generation. Can you bring life to the rest of the solar system, starting from Earth? So here's the picture of our solar system with all those amazing objects in it, and it becomes a place for. Right now, we're seeing the potential to transform from life on one world to life on many worlds in the solar system. But beyond is the distant stars and galaxy and other galaxies. So each of those dots up there is another solar system, and we have discovered perhaps 5,000 other planets around other stars, I don't think we'll be able to travel to other stars in any time in the future, in near future. But the same technologies of computing and sensors and telescopes are giving us an ability to look deeper and deeper into the galaxy. And so we have a potential to look for patterns in the galaxy. If you click again, this will zoom in on this one little interesting pattern, which is it turns out it's a supernova remnant. But it illustrates how there's a lot of deep complexity in the galaxy that we're just beginning to discover. The James Webb Space Telescope will be releasing its first images next week, along with the first batch of terabytes of data of other images. And so the galaxy is going to be revealing all these complexity and natural phenomena, but I believe that in the next few decades we will start to see evidence of aliens' intelligence, perhaps through structures that will. And so we'll keep an eye out for what could be discovered. I'm not convinced by UFOs popping up with little lights, but I think we're going to be dazzled by what is discovered out deep in the galaxy. Just like looking back, when I was growing up in North Carolina, I didn't expect to be traveling the world and living in another country. But I think young people today may not realize it, but they will have an opportunity in the future to travel into the solar system. So that's what we call it, limitless.